This is the practice test 11 over trig. I'm just going to go ahead and get started. Number 1, which of the following shows the correct side lengths? Okay, if we look at this is a 30, 60, 90. So if you have your notes, this would definitely help. So this is my x square root of 3 side, this is my x side, this is my 2x, the hypotenuse. Okay, so to go from this, the 60 degree, the longer leg, over to the shorter leg, I would divide by square root of 3. So since I have a square root already, this would be, let's see, square root of 21 divided by square root of 3. Because they are both square roots, I can divide the two numbers. So that would give me square root of 7. I can't reduce that at all, so x is square root of 7. And then to go from the shorter leg to the hypotenuse, I just multiply whatever my number is here times 2. So I would have 2 times square root of 7, which is just 2 square root of 7. Because they're not both square roots, I cannot change them. And so y is 2 square root of 7, x is square root of 7. So x is square root of 7, y is 2 square root of 7. My answer would be F. If you notice, A is flipped, and then L and Q are totally wrong. That would be true if it was a 45, 45, 90 triangle. Or at least X would be, or L, sorry. Anyways, so for that one, 30, 60, 90, you divide it by square root of 3 to get to the shorter leg, and then times 2 to the longer leg. Yeah, that's it for that one. Alright, number 2, which of the following shows the correct trig ratios? So we have only tangent and secant, so you only have to worry about two things. You just got to make sure the ratios are correct. Of course, only one of them should be. Now, looking at this triangle right here, of course, I'm starting at this angle because I told you, or that's the only angle we have. So across is opposite. This one is hypotenuse. And then we have adjacent. Okay, so since I'm only doing tangent and secant, let's do tangent is opposite over adjacent. So we have opposite is 18 over adjacent is 24. I can divide both by 6 and get 3 over 4. So tangent should be 3 over 4. I can go through here and find that these two are wrong. So I'm between W and G. Now I need to find secant. Okay, so if secant is 1 over cosine, right? So whatever cosine is, you flip it. So if cosine is adjacent over hypotenuse, secant would be the opposite of that, right? Hypotenuse over adjacent. Okay, hypotenuse is 36, adjacent is 24. 12 can go into both of those, that'd be 3 over 2. So secant is 3 over 2. G is wrong, which would leave W as our answer. And that's number 2. Now, you're not guaranteed on number 2 to get tangent secant, so you need to know all 6 ratios. But whatever 2 are on your test, that's how you would find out. I would just write it out work it out like I did, and match it up. There should be one that matches, and if there's not one that matches, it would be none of these. Number 3, which of the following shows the correct missing side length? Again, we only have tangent or sine. Okay, so I'm just going to do the same thing. We're starting at 25 over here. So across is opposite. We have a hypotenuse, which I don't have a number or anything, so I can't even use that one. I don't need it. And the only one left is adjacent. So because I have opposite and adjacent, it has to be tangent or cotangent. So if I'm looking at these, sine would definitely not be right because I don't have hypotenuse to even use. Okay, from here, I'm just going to work it out. So I would have tangent of 25 equals opposite is x over adjacent is 9. Now to get x by itself, I move 9 over here and multiply. So I would have 9 times tangent 25 equals my missing side length. So I need 9 times tangent 25, which is right here. So answer for 3 is x. Which of the following, number 4, shows the correct missing angle? Okay, same thing. We have an angle and I only have 2 sides, so I'm forcing you to use a specific trig ratio. So again, across is opposite. We have hypotenuse, and then I don't even need adjacent, so I'm not going to write it down. Okay, opposite and hypotenuse is already sine. Okay, so I have secant or cosecant. Well, if I have sine and I flip it, I would get cosecant, which means secant is out. Okay. So now I just got to do, this would be sine, or sorry. Yeah, sorry. Sine theta would be opposite, so 10 over 55. So then if I do the inverse, right? 10 over sine inverse is 10 over 55 equals theta. Now, of course, I don't have sine on here. I have cosecant or secant. So we know we flip it to get cosecant. And so I flip this fraction. You would have 55 on top over 10, which reduces. 5 goes into both, 11 and 2. That equals theta. So I want cosecant -1 and then 11 over 2, which is right there, letter D. So again, work it out and then match it up. If one doesn't match, it'd be none of these. And just so you know, none of these is possible on the test. Convert 285 degrees to radians. Okay, well, to convert, I would do degrees times pi over 180. Okay, so if I do that, I'm just going to get 285 pi over 180. 5 can go into both of those, right? So let's see, 5 goes into 285. I don't know. Let's find out. So 5 goes into 28 5 times. And 7. So we have 57 pi. And then 180 divided by 5. 5 goes into 18 3 times. 36. And I can still keep going, because if you notice that 57 over 36 is not an option, which means I can keep going or it's none of these. Now, on the practice test, I don't do none of these, so there is an answer. But on the real test, just be careful. Okay, so I can keep dividing this. I know I'm going to have some pi over some number, all right? And if I'm reducing this, I can't have 57 or 36, okay? So just knowing that, if I go back here, these 57s are going to be wrong. So it's either 19 over 6 or 19 over 12. Or on the real test, it'd be nothing, right? None of these. Okay, you got to figure out what goes into both. Well, it may not be as obvious on this one, but I can tell you 3 goes into both. Now on the test, I made it a little easier to tell what number goes into both, or at least I hope I did. This one, of course, this is a little harder because it's the practice test, but if you can get this, you can get the real test. So I can do 57 divided by 3. 3 goes into 5 once, and then 19, which you already knew is 19. Okay, and then 36 divided by 3, oh, we already know that's 12, hopefully. So 19 over 12. So the answer would be P for that one. Number 6. I want to convert now and go the other way. Convert that to degrees. So I do my radians times 180 over pi. By doing that, the pi's automatically go away. So no more pi. Sorry if you were hungry. Okay, I leave it like this just so I can reduce the denominator with 180 first. I mean, you're free to multiply then divide, whatever works for you. So 4 goes into 4 once. 4 goes into 180. Let's make that green. So 4, okay, let's see. 184, right? 4 goes into 18 4 times. That's 16, 5. Okay. So 45. So I would have actually 13 times 45. Let's find out what that is, because I do not know. 5 times 3 is 15, 12, plus 1, put a 0, and then add 585 degrees. We do have that, F. So that's all you do for number 6. This is multiplied by 180 over pi. Number 7, which shows a positive coterminal angle. Okay, so if you want a positive, you just want to add to that. If it says negative, you would want to subtract until you get to a negative. Okay, now these are radians, right? So I'm going to add 2 pi, but I can't add just 2 because it's not the same denominator. Remember, whole numbers are over 1, and I have to have these numbers be the same. So if I multiply 1, my current denominator, times 15, to make it the same, I would have to multiply 2 by 15, and I would get 30 pi over 15. I can add 30 pi over 15 and 7 pi over 15 and get a positive coterminal angle. So 30 pi plus 7 pi, that gives me 37 pi over 15. I can't reduce that. I'll go ahead and tell you, you won't be able to on these. So 37 over 15 gives me m, and that would be my answer for this one. Now 8, negative coterminal. Okay, so for radians on number 7, or you might have radians on 8, it just depends on your test. So if I get radians, I add or subtract 2 pi. I just got to change the denominator. If I get degrees, like number 8, and you might have it on 7, it just depends. So to get positive or negative coterminal angles for degree measurements, you would add or subtract 360. So really I'm doing 106 minus 360, but I don't like doing that, so I subtract the biggest minus the smallest, and I just know it's going to be negative because that's what I'm looking for. It tells me it's negative, right? So if I subtract this, that'd be 10, 5. So 10 minus 6 is 4, 5 minus 0, and that's negative 254. H. And so yeah, either way, you add or subtract depending on what it tells you. Alright, number 9. Exact value of tangent 225 degrees. Okay, so this is where you would want the unit circle if you don't know these. I know that on a unit circle, 225 is down here because you have 180, right? 210, 240. So because this one's in the middle, I know the degrees, or the coordinates, sorry. Square root of 2 over 2 and negative square root of 2 over 2. So tangent is sine over cosine, right? So I would have sine over cosine, and because I have something divided by itself and they're both negative, it'd be positive 1. Okay, and I know I made that look so easy. So there's a good chance though you might just have a sine, cosine, secant, cosecant, in which case you just find the right point, right, the x or y, and you either just have the x or y or you flip it. So like number 10, I have cosecant. So I got to find, actually I want to find sine of 2 pi and then flip it to get cosecant. Well, again, I know the unit circle 2 pi is right here. The coordinates are 1, 0. That's cosine and sine. And I want sine. So sine is 0. And I flip it to get cosecant. So if I have 0 over 1 and I flip it to get 1 over 0, I cannot divide by 0, so my answer would be undefined. Okay. Now, if you need some extra help, because maybe this might be a little hard for you on the 9 and 10, I actually have on Canvas, I posted, I think it was last week, 2 weeks ago, maybe 2 weeks ago now, a trig circles page, or pages. I actually made a unit circle for that showed tangent, cotangent, secant, cosecant, and the sine cosine. So if you have those, I can just look up tangent 225 and I have the answer there for you. I can look up cosecant 2 pi on the cosecant unit circle and I have the answer there for you. So if you're watching this and you haven't seen that, I would go back and find it, print it off, or write it down, whatever you can, and you have that as a reference. If not, then you just got to do it the way I did it. All right, last 5. Number 11. Reference angle for 271. Okay, first thing you got to figure out is which quadrant that angle is in. If I know this is 180, I know this is 270, I know this is 360, 271 would be right down here, probably a little closer, but just to illustrate. So here's 271 degrees. A reference angle, if you forgot, is how far it is from your angle to the x-axis. So you're always going to go to the x-axis, this horizontal line, and then whatever your degree measurement is closest, that you just subtract them and that's your answer. So my closest one is 360, and I'm going to subtract 271. That's all I need to do. So I have 360 minus 271, and go from there. So that becomes 10, that's 15 and 2. 10 minus 1 is 9. 15 minus 7 is 8. 2 minus 2 is 0. So my answer, 89 degrees. Okay, so let's say, just real quick, if I was over here and I'm going this direction, I would, or if I'm up here and I'm going down here, I'm going to subtract 180, or from 180, it just depends on where I am. And remember, your reference angle should always be positive, either way. So if I'm in quadrant, was this 2 and 3, I'm going to 180. If I'm in quadrant 4, I'm going to 360. If I'm in quadrant 1 and I go down this way, right, I'm going to 0 degrees. So if you have quadrant 1, it's actually the easiest because the answer is the angle itself. Everything else you have to subtract to find out how far it is from the x-axis. Okay, so no matter which quadrant you're in, you're going to the x-axis, the horizontal line. So you just subtract on that one. Number 12, reciprocal identities. Okay, I say use this type on purpose because if you notice on 13, I say use Pythagorean identities on purpose. You need to make sure you use the right one. Otherwise, you have not shown me that you know this stuff or can use it. You just show me you can use Mathway. Okay, sine equals 1 over cosecant, right? That just means I flip whatever cosecant is. So I have 1 over 2 square root of 3. Can't have a square root in the bottom, so I multiply. That would give me on top square root of 3, and on bottom you have 2 times 2 square roots of the same number is just the number. And so my final answer is square root of 3 over 6. And that would be it. Okay, Pythagorean identities. The one I would have to use, since I have sine and cosine, the only one that I have with sine and cosine is sine squared theta plus cosine squared theta equals 1. I want cosine, so I would move sine over here. Okay. So I'm going to use this right here and find cosine. So when I plug this in, I have 1 minus sine is what I have in my problem, squared. Okay, if I square that fraction, I would square this number, so I have 9 square root of 5 times 5. Square 10 is 100. And since my denominator is 100, I would change this 1 to 100 over 100. Okay? Now let's keep going. We have 100 over 100 minus 9 times 5 is 45. Okay? That gives me 55. Now, I don't want to reduce only because this gives me, that fraction right now is cosine squared. I want cosine. So your last step on this question should be to square root. So if I square root the top, I would have just square root of 55. I can't do anything with that. And the square root 100 is 10, which is why I don't want to reduce, because if you reduce, you'll end up with more than you need, honestly. So I would just leave it like that. Yeah, reducing would just create more work, and you don't want that. You'll end up with the same answer anyways, just with extra steps. So don't reduce, take the square root, and then the bottom is not a square root, so I don't have to do anything else. I'm done right there. Okay, but make sure you use the right identities on these two questions. Don't use Mathway. Our last two, simplify using any trig identities necessary. Okay, I'm just multiplying and dividing. I have no plus or minus, so I can't use Pythagorean identities. Alright, so fail safe if you can't do anything else or don't know where to start. Change everything to sine and cosine. So cosecant, right, is 1 over sine times cosine is already cosine. And then cotangent is cosine squared over sine squared, right? Okay. So let's look at the top right here. I have 1 over sine times cosine over 1. That would give me cosine over cosine, right? No, sorry. Wow. Cosine over sine. The bottom is just cosine squared over sine squared. Okay. Now, since I'm dividing by this fraction on the bottom, this fraction can come up, or it has to, but then I flip it. So I just flip this and multiply. Okay, now look at this. I can go from here, 1 cosine and 1 cosine, that leaves me with 1. 1 sine and 1 sine, that leaves me with 1. So I actually have 1 sine left on top, 1 cosine left on bottom. Sine over cosine also equals tangent, but it's just 1 tangent, not 2, so be careful. And that's it for 14. So again, if you don't know what else to do, change everything to sine and cosine, and you can do something like that. Because if it's all sine and cosine, it makes it a lot easier to combine or reduce and cancel stuff out. Okay, 15, prove. Okay, I gave you the answer, you have to get there. First thing I would look for, I have 2 squares and a minus. That could be a Pythagorean identity. In this case, it is. Okay, so if I have cotangent squared plus 1 equals cosecant squared. Okay, so if I were to move cosecant over here and move 1 over here, right, that's cotangent squared minus cosecant squared equals -1. So that means this part right here is just -1 over cosecant and cosine. I'm going to change to 1 over sine times 1. No, not 1. Wow. Cosine. I don't have to change that one. Okay. So going from here, I have -1 over. Remember, this is just like we just did. This is cosine over sine. Okay. This fraction can move up, and I flip it. So I have -1 times this that would be negative sine theta over cosine theta. And we just found out that negative, or sine over cosine, is just tangent, right? So negative tangent theta and negative tangent theta. Check that out. We got our answer that we wanted. And again, as long as you end where it tells you to right here, then you're good to go. And everything should make sense, which in this case it does. And the only thing I can tell you right now is the only thing you can do is practice. If you haven't, you need to. Like, try it without looking at the answers and see if you can get it right. Other than that, good luck on the test.